Okay, the last activity that you have in chapter 1 is actually another problem set, but this time I do not give you any strategies. Differently from the other activities that you have had during the chapter, that you actually, I labeled you what strategy to use. This one I don't. So it is up to you. I would suggest that as we discuss, you pause, work the problem, and then come back and check. So in the first one, it says Bad Bargo sneaked into Homer's pigeon's loft one day. He took half of the pigeons. He decided that wasn't enough, so he took one more and left. Later, Homer opened the door of the loft in order to exercise his prized possessions. Half of the remaining flock flew out, leaving 6 inside the pen. How many pigeons did Homer have before Bad Bargo did the dirty deed? And again, this is just a picture that I found in Shutterstock. This is not, because see, there's 7, not 6. Just FYI, don't go by the number of pigeons in the picture, go by what it says on the thing. So this exercise is good because students don't know how to use, or what does it mean working backwards, and that's one of the things you're going to be using. Every time you work backwards means that you are going to do the inverse operation, and that is a key word when you are describing using working backwards that I'm going to look, that you use the word inverse operation. Why inverse operations? Because if you have 20 and 6 flew out, then now you have 14. So you're subtracting. But if you start with a 14, going back to see how many you started with, so the flew out, instead of subtracting, is going to turn into an addition that you're going to add to the 14. And that's how you go back to the 20. So that's what we call it, inverse operations. So keyword, working backwards. And then again, we're going to start with the last one. He had 6 left. And half flew out. That means you're going to half. That means you're going to multiply by 2 to get 12. And going back to Bad Bargo, he said he took one more. So that means that to the 12 that were left when Bad Bargo left, we're going to add one more to it. So that's 13. And then the original says that half of them flew out, or he took half of it. So that means out of those 13, you are going to multiply by 2. So out of the 26, if half flew out, that will be 13. And if you took one more, that will be 12 left. And if out of the 12, half flew out, then you have 6. You see how it works once you go back to the original? But all these are inverse operations. Okay, so Homer had 26 pigeons at the beginning. The next problem, this one, guess what? If you have dominoes, use dominoes. If not, a piece of paper would do. Okay? And again, so I'm telling you right now, this is using manipulatives. And then, yes, you can do guess and check. Now, they say this is called a domino donut, where the rows and columns add up to the same addition. So this one add up to 11. See, this is 10 plus 1, 11. 10 plus 1 is 11. And then 7 plus 4, that's 11. And then 10 plus 1 is 11, right? So that's a domino donut. So you need to use these, not these. These right here, because these are, some of them are different. They're not the same. Like you didn't have a 6 and 2 in this one. See how they're different? Or a 4 and 3, you didn't have it in here. So these are different. So you're going to do, see, this is my 4 and 3. This is my 5 and 1. This is my 6 and 4. And this is my 6 and 2. See? Those are my dominoes. These are my manipulatives. And now, basically, it says not to add up to 11, but to add up to 12. So you need to rearrange this so it adds up to 12. Of course, this is not it, but, right, this is something like that you need to form. But obviously, this does not work because this adds up to 10, this adds up to 14, this adds up to 9, this adds up to 13. So obviously, this is not the donut, but this is the point. This is what you have to be able to form, right, to move it around. So after you do some guess and check and you move around your little dots, you are going to see that, let me put it this way, 4 and 2, 6, 4, 5 and 1. See, any combination of that, you can, obviously you can rotate it, but any combination of that works. See, 6 plus 4 is 10, plus 2 is 12. 2 plus 6 is 8, plus 4 is 12. 4 plus 3 is 7, plus 5 is 12. And 5 plus 1 is 6, plus 6 is 12. So you see, this is the domino donut that has the sum of 12 with those dominoes. Okay? And again, what do we use? We use our manipulatives and our guess and check. So for those of you that need a little more time to write it down. Okay. What's the next one? The next one, which you actually have on your learning notes, you have exactly the same problem on your learning notes. So we're going to look for patterns. We're going to do a table, right? We already had the drawing. So I did not do another drawing because, again, I already had the drawing. You need to figure out how many in that one. So I went ahead and I did a little table, right, where I can actually find my finite differences. So I did the first difference, and then I did the second difference, and then I did the third difference. And then I worked backwards, right, until I could figure it out. What is the number of cannonballs in this figure? And that was for the sixth one, so that is 91. And you needed to continue all the way to the 10th pyramid. So how many total cannonball? So for that, if I continue doing in the pattern, I'm going to see that if I add 2 to 13, these are odd numbers. But actually, the first difference is they're perfect squares. See, 4, 9, 16, 25, 36, 49. So the next one, this is 7 squares, so the next one will be 8 squares. So it will be 64 plus 140. That's a 204. And then it will be 9 squared, which is 81. So 81 plus 204 will be 285. And then 10 squared, it will be 100. So you add it to 285, which is 385. And there you have it. You have all the answers for each one of these. These are the finite differences, so the answer is yes. And the finite difference is yes, right? And this is it. And then describe the 10th pyramid. There are 385 cannonballs in the 10th position. And then the other one that is very similar to the one that you have in your homework, right? The one that you have in your homework is about distances, right? In this one, they say you're driving from town A to D, passing through B and then C. And then they say that from A to B is 10 times farther than from B to C, and then from B to C is 10 times farther than from C to D, right? And then the total number of miles is 1,332. So there are, again, like everything, there's still several ways of working this depending on the student's grade level. But strategies, you can draw a picture, you can do guess and check, you can work backwards, you can use variables and unknown, right? For this part, it will be for algebraic. Now, I will definitely do a picture. And then, and since this is, because they didn't tell me any information, so if this is 1, and this is how I will start with my students, right? So this is your drawing. This is D, this is C, this is B, and then this is A. So again, I'm going to use my guess and check at the same time. So I know that this one is 10 times that one, and this one is 10 times that one. So if this is 1, this is 10, and this is 100, right? If that was the case. But when you add 100 plus 10 plus 1, that's 111. That is now 1,332. So you say, okay, well, let me see if I use 10. So now if this is 10, this is 100, and this is 1,000. This is better, but it's still not 1,332. It's 1,110. And then from there, I'm more cautious, right? Because I'm pretty close, but not as close as I'm supposed to be. So I just go up by 1. So now I said, okay, instead of 10, this is 11. And then 11 times 10 is going to be 110. And 110 times 10 will be 1,110, right? Just like I have it right here. Pretty close, but not there yet. So once I reach 12, I got 12. 12 times 10 is 120, and 120 times 10 is 1,200. And when you add these together, that is the answer that gives you 1,332. Now that you know all the pieces, all the parts, then you can answer the question that says, what is the difference between A and B? So they don't ask you for all of it, they just ask you for the first one. So the difference between A and B is 1,200 miles. Okay? 1,200 miles, because that's what they're asking. That's why it's important in your information about what is the question asking, right? The first one, it's important that you answer what it's asking. And then the other one that was also on your learning notes, except for the last one in here, but it's exactly the first 3 were exactly the same. It was to categorize these 4 sequences between geometric or arithmetic and to describe the rule, right? So again, here you're adding 5, so continue for the next 3. Arithmetic, add 5 to previous term. In this one, multiply by 2 previous term, so it's geometric. In this one, was subtract 4 to previous term, so that is arithmetic. And then in this one, must multiply by 3 previous term with this geometric. Okay? And that's it for this one.